All right, welcome back. So let's talk about an initial value problem, which also is going to highlight something interesting about how we choose U and V. So we're starting, and I've actually gone ahead and written a few things here. I'm going to try to write smaller on this one because I have a picture on the next side. We're starting with an initial value problem where we are given the dy dx. So on the next page, I've got a slope field. I generated it using GeoGebra Online, which has a nice slope field generator. And we're going to try to find the function that goes along with this. So integrating both sides, we get y is equal to the integral of x natural log of x dx. And what I have chosen to do here is I've actually chosen, and I've reorganized it to show this a little better. I've chosen it U to be equal to the natural log. This is going to be a general rule that if you have a choice, or excuse me, when you have a choice, if there's a natural log in there, you make it equal to U. And the reason is because I'm going to take the derivative of U, which eliminates the natural log from my problem. If I make dv equal to natural log of x dx, this becomes a complicated problem. So this is a situation where the general rule that we said before, which was U should get simpler, dv should get no more complicated, is actually we're going to turn that around a little bit because dv is going to get more complicated. So U is equal to natural log of x, which means that du is equal to 1 over x dx. By the way, I didn't get around to starting my computer, so sorry. Hopefully it's not too distracting. And dv is equal to x dx, which means that the antiderivative is 1/2 x squared. So this is equal to U times V, 1/2 x squared natural log of x minus the integral of V du. 1/2 x squared times 1 over x dx. Notice what choosing U as natural log got us. We just have a straight up polynomial here on the second half. So this is equal to 1/2 x squared natural log of x minus, well, one of these x's cancels out, and this becomes 1/2 x squared plus a constant. So might as well figure out the constant right now. We plug in y equals -1. We plug in x equals 1. Hopefully we are comfortable with the fact that natural log of 1 is 0, so that goes away, giving us a constant of -3/4. And we get the equation y equals 1/2 x squared natural log of x minus 1/4 x squared minus 3/4. So because we started with dy dx, what we can now do is we can generate a slope field for x natural log of x. We can plug this in on top of our slope field and see if it matches. I've gone ahead and done that in advance. And as you can see, this is actually a very nice match. There's our initial value point. Slope is relatively non-steep, but getting steeper over here. Slope very quickly gets steeper as we move to the right. And it really does match up nicely with our slope field. All right, so my students, why don't you go ahead and do exercise 11 out of the book. And we'll be back with another example where we'll look at an integral that we just can't ever solve, but we're going to do something clever with it. Thanks for watching.